In this video, we're going to graph rational functions, okay? So there's a series of steps you want to go through when you're graphing these functions. It's a kind of a time-consuming and tedious process, but it's something we got to be able to do. So the first thing you want to do is factor. If possible, you want to factor the rational function. Now, obviously, in this case, number 5, that one's already in simplest form, okay? So it can't be factored, all right? Second thing you want to do is find intercepts, okay? Finding the x and y intercepts, no matter what kind of function you're dealing with, that's one of the things you always want to do because it helps make graphing easier. Okay. In this case, there is no x-intercept. All right. The numerator is 2. It's a constant, so that means this function can never be 0. All right. So there is no x-intercept. So 2 divided by any number is not going to be 0. So no x-intercept. To find the y-intercept, we just want to plug in 0 for x. So we get 2 over 0 minus 3, which is negative 2/3. So the y-intercept is going to be negative 2/3, okay? I'm going to graph this a little bit later. If you want to go ahead and plot that point on your graph, it would be a good idea, all right? Now, in a previous video, we talked about how to find vertical asymptotes, okay? We're going to talk about removable discontinuities as well a little bit later. For now, all of these functions on this notes page are going to have a vertical asymptote. All right, so to find the vertical asymptote, you're just going to take that denominator, you're going to set it equal to 0, and you're going to solve. So the vertical asymptote here is at x equals 3. So at x equals 3, there's going to be a vertical line there that this graph will never touch, never cross. Okay, horizontal asymptotes. In the previous video, remember we talked about how to find those. We want to compare the degree of the numerator, which in this case is 0, to the degree of the denominator, which in this case is 1. Okay, if the degree of the numerator is less than the degree of the denominator, which is the case here, the horizontal asymptote is going to be at y equals 0. Okay, so the x-axis here is going to be the horizontal asymptote. And remember, all that means is as we progress towards negative infinity to the left and positive infinity to the right, the graph's going to approach the x-axis here, okay? So, next thing we want to do, we're going to talk about the behavior as we approach the vertical asymptote from the left and the right, and we're going to talk about the end behavior, what happens as x approaches negative infinity, and what happens as x approaches positive infinity, okay? And that's going to give us some points that are going to help us graph, okay? So first thing, let's talk about the behavior as we approach the vertical asymptote. We're going to start on the left, okay? So as x approaches 3 from the left, I'm just going to plug in 2 to the function, okay? 2 is to the left of 3. It's pretty close to 3, but I'm going to get progressively closer to 3 so you can see what happens to y, okay? So when you plug in 2 to this function, you get 2 over negative 1. So when you plug in 2, y is going to be negative 2, okay? We want to get, like I said, progressively closer to this x equals 3 value to see what's happening to y. So let's go a little bit closer to 3. Let's plug in 2.5, okay? You get 2 divided by negative 1/2, which is negative 4. So you can already see we're staying negative. The magnitude of that y coordinate there is getting larger, okay? So that's a good sign. Let's just make sure that continues to be the case. So let's get a little bit closer to 3. Let's plug in 2.9. To the function, we get 2 over negative 0.1, which is going to be negative 20, okay? So again, stayed negative, magnitude is just getting larger, okay? So what we can say there is we're approaching this vertical asymptote here at x equals 3, okay? Y is going to approach negative infinity, okay? So as we get closer and closer and closer to that value from the left, the graph's going to be going down, okay, like this, okay? Now, let's do the same thing, but come from the right side. All right, so let's start a little bit farther away from 3. So we're going to start with 4. When we plug 4 into the function, we get 2 for the y coordinate. Let's get a little bit closer to 3 coming from the right side. So let's plug in 3.5. Okay, when we plug in 3.5, we get positive 4. So you can see we're getting closer to 3. We've got 2 positive values, but they seem to be growing in magnitude. All right, let's get a little bit closer to 3. Let's plug in 3.1, okay? And when we plug in 3.1, we're going to get a positive 20, all right? So as we're coming from the right, okay, it looks like the y coordinate's getting bigger and bigger and bigger. So we're going to be saying that as we get closer to 3 from the right side, the y coordinate's going to approach positive infinity, okay? So we know the graph is going to look something, you know, like this. If you follow the cursor, we're going like this over here, and on the right side, we're going to be doing something like this, okay? All right, now, in behavior, what happens as x approaches negative infinity, and what happens as x approaches positive infinity? So I'm just going to plug in a fairly large negative number here and show you what's happening. So let's say we plug in negative 1,000. It doesn't matter what you plug in. I just chose negative 1,000. We're going to get negative 0.002. So you can see we're getting closer and closer to 0. If you go all the way back to 2.9, we're getting smaller and smaller and smaller. Well, what's happening? We've got all negative numbers, but they keep getting closer and closer and closer to 0. Okay? But they always are negative. So what we say there is x approaches negative infinity, y is going to approach 0 from below. Okay, so we're going to stay right around here. All right, let's plug in a large positive number. Let's plug in 1,000 there. When we plug in 1,000, we get 0.002. Notice to the right of that asymptote, as we get bigger and bigger and bigger, the value stays positive, but it keeps getting closer and closer to 0. So the end behavior of this function is as x approaches positive infinity, y approaches 0 from above. Okay, so now I'm going to draw the graph, and you'll see how we put all this together into one graph for the function f of x equals 2 over x minus 3. So putting the graph together, we had a vertical asymptote at x equals 3, so I've already drawn that here. We've got the horizontal asymptote at the x-axis, y equals 0, okay? Now we had a bunch of points in our table. We don't have to plot all of those, of course, but we do need to plot the ones that are obviously needed, okay? So first thing, the y-intercept is negative 2/3. So we're going to plug that in there. That's an easy one to plot. We also had 2, negative 2. Okay, and that's really enough. Okay, so remember our behavior approaching the vertical asymptote as we were getting closer and closer to 3 from the left. We were going down to negative infinity, and the end behavior going towards as x approaches negative infinity. Remember, we were approaching 0 from below. Okay, so we're never going to get to that horizontal asymptote. Okay, on the right side, okay, we had a couple points we could plot here. We've got 4, 2. Okay, we had 3.5, 4 just to have kind of another one on there. 3.5, 4 would be right there. You could, if you want to plot more, you can. But again, using the behavior, remember as we were approaching, as x approached positive infinity, y approached 0 from above, and as we approached the vertical asymptote from the left, we were approaching positive infinity. Okay, so there's the graph for f of x equals 2 over x minus 3.